Hi, guys. Welcome to our channel. Before we get started, make sure to hit that like button, also subscribe to our channel. A look at the biggest telescopes in the world. So make sure to watch the full video. Telescopes are optical instruments that magnify distant objects to the human eye by using an arrangement of lenses or curved mirrors and lenses, or various devices. The Hubble telescope has been in news always due to its spectacular images captured. It has recently found 6 new galaxies and has left astronomers in awe. It was launched on April 24, 1990. It is located about 340 kilometers above the Earth's surface and orbits around it 15 times per day. Before Hubble, space exploration was a bit slow and grounded, but since its initiation, space exploration has known no bounds. Hubble was not the first space telescope but one of the largest ones. Telescope, about. Telescopes are optical instruments that make distant objects appear magnified by using an arrangement of lenses or curved mirrors and lenses, or various devices used to observe distant objects by their emission, absorption, or reflection of electromagnetic radiation. The word telescope was coined in 1611 by the Greek mathematician Giovanni Demisani for one of Galileo Galilei's instruments presented at a banquet at the Accademia dei Lincei. Next-generation ground telescopes received priority designation from a long-awaited report by the National Academy of Sciences. They would join a host of existing ground telescopes and smaller space telescopes already peering at supernovas, galaxies and other distant objects in the starry skies. 3 planned optical telescopes in the 98-foot, 30-meter, range would house some of the biggest mirrors yet for collecting light from distant cosmic objects. And proposed radio telescope would dwarf predecessors by using many antenna stations to create a total collecting area of a square kilometer, or 0.4 square miles. Here's a look at 10 of the present and future giants among ground-based telescopes that provide scientists a glimpse of the past universe through time and space. Large Synoptic Survey Telescope, LSST. A new ground-based observatory that would scan the entire available sky every 3 nights from Chile could see first light by 2014. The $465 million Large Synoptic Survey Telescope would give astronomers their best view ever of how billions of faint starry sky objects change over time. It could also tackle questions relating to the nature of dark energy, and perhaps track space rocks that might collide with Earth in the future. The optical telescope would image each region of the sky 1,000 times over 10 years with an almost 28-foot, 8.4-meter, aperture. It represented a top priority among ground projects slated for the next 10 years in the Astro 2010 Decadal Survey by the National Academy of Sciences. South African Large Telescope, SALT. This 30-foot, 9.2-meter, telescope represents the largest ground-based optical instrument in the Southern Hemisphere, and concentrates on spectroscopic surveys. A main mirror consists of 91 hexagonal mirrors that join together to form the larger hexagonal primary, not unlike the Hobby Everly Telescope, HET, in Fort Davis, Texas. Like HET, SALT also has a fixed-angle design that has complicated observation since it began operation in 2005. But the instrument can still view about 70% of the sky observable from Sutherland, South Africa. Keck 1 and 2 telescopes. The twin 33-foot, 10-meter, telescopes at the W.M. Keck Observatory represent the second largest optical telescopes on Earth, located close to the summit of Hawaii's Mauna Kea. Each instrument's main mirror consists of 36 hexagonal segments that work together. Keck I became operational in 1993, followed just a few years later by Keck 2 in 1996. The combined observatory has helped astronomers examine events such as last year's impact on Jupiter. It also deployed the first laser guide star adaptive optics system on a large telescope in 2004, which creates an artificial star spot as a reference point to correct for atmospheric distortions when viewing the sky. Gran Telescopio Canarias, GTC. A 34-foot, 10.4-meter, telescope located on La Palma of Spain's Canary Islands seized the top spot as the world's biggest ground-based optical telescope in 2009. A main mirror that consists of 36 hexagonal segments contains some of the smoothest surfaces ever made. The telescope also has several support instruments such as Canary Cam, a camera capable of examining mid-range infrared light emitted by stars and planets. The Canary Cam also has the unique ability to figure out the direction of polarized light and use coronagraphy to block out bright starlight and make fainter planets more visible. Arecibo Observatory. One of the world's most recognizable ground-based telescopes has resided as a huge 1,000-foot, 305-meter, radio reflector dish near Arecibo, Puerto Rico since 1963. the Arecibo radio telescope still represents the largest single-aperture telescope ever constructed, with its spherical reflector consisting of 40,000 aluminum panels each 3 feet by 6 feet. The huge reflector helps make Arecibo an incredibly sensitive radio telescope, capable of homing in on a faint radio source within just several minutes of observation. Such radio sources include distant quasars and galaxies that emit radio waves which only reach Earth 100 million years later. Atacama Large Millimeter/Submillimeter Array, ALMA. One of the largest ground-based astronomy tools comes in the form of the 39-foot, 12-meter, radio antennas that will total 66 by 2012, to make up ALMA's main array. Each antenna weighs more than 100 tons each and requires huge crawler vehicles to move it to Chile's Chinaner Plain at an altitude 3 miles up. This will ultimately help make ALMA the largest and most sensitive radio telescope ever, at least until a new contender emerges. The antenna array can also undergo different configurations by moving individual antennas around. A compact configuration would place all the antennas within an area less than 1,000 feet across, or within an extended configuration with a maximum distance of separation between the antennas of almost 10 miles. This will allow the array to study everything from the cosmic dark ages billions of years ago to the processes of star and planet formation. Giant Magellan Telescope, GMT. One of the next ground-based optical telescopes will take the form of the $1.1 billion Giant Magellan Telescope with an 80-foot, 24.5-meter, main mirror that consists of 7 segments. One 8.4-meter segment would sit in the middle, surrounded by the other 6 segments that have a unique curved shape not unlike that of a potato chip. The large main mirror would dwarf the current generation of 26 to 33-foot, 8 to 10-meter, telescopes and produce images about 10 times sharper than the Hubble Space Telescope. If fully funded, the telescope could find a home at the Las Companas Observatory in La Serena, Chile and begin full operations by 2024. 30-meter telescope, TMT. Another of the next-gen contenders for biggest optical telescope on Earth is the 30-meter telescope. The $1.4 billion telescope's 98-foot, 30-meter, aperture would allow for more than 9 times the collecting area of the largest optical telescopes such as the Keck telescopes, and could provide 12 times sharper resolution than the Hubble Space Telescope. But TMT and other extremely large optical telescopes would not replace space telescopes. Hubble's successor, NASA's James Webb Space Telescope, would find targets for Earth-based giants such as TMT to study in more detail. The 30-meter telescope is slated to join the Keck telescopes and other instruments on Mauna Kea in Hawaii and commence full operations by 2025 to 2030. Square Kilometer Array, SKA. A follow-up to radio telescopes such as ALMA is a telescope capable of collecting data over 1 square kilometer. The aptly named Square Kilometer Array would become the clear king of radio telescopes, with 50 times the sensitivity of any radio telescope ever built. Such power could examine signals from the younger universe of 12 billion years ago. Current plans call for either 30 stations with a collecting area of 656 feet, 200 meters, each, or 150 stations each equivalent to a 295-foot, 90-meter, telescope. South Africa and Australia have already begun jostling in a bid to play host to the $2 billion behemoth, scheduled for completion around 2020. It co-ranked as the highest priority project in the European Astronet Decadal Survey, along with the European Extremely Large Telescope. European Extremely Large Telescope, EELT. Ground-based optical telescope contender can currently match the design proposal for the European Extremely Large Telescope. Its 138-foot, 42-meter, mirror would put it easily beyond the 30-meter telescope and Giant Magellan Telescope, with a length reaching almost half a soccer field. 5 mirrors consisting of almost 1,000 hexagonal segments would make up the primary mirror, and give Earth-bound astronomers the sharpest view ever of the cosmos in the visual light spectrum. Cerro Armazones in Chile will be the future home of the world's largest optical telescope. The 1.3 billion EELT would see first light around the same time as its smaller next-gen cousins in 2018. The largest refractor telescopes are renowned for their absolute sharpness of image because they are composed of very large lenses of compounds of glass which gives them crystal clear images. But they are extraordinarily difficult to make in a large size. Their own weight distorts their shape and makes them unusable above a certain size. The largest refractor in the world is the Yerkes telescope, which has a primary lens that is 40 inches in diameter. It was completed in 1897 and was built by the famous master optician Alvin Clark. It represents the pinnacle of refractor telescope making, and no larger one has since been built in the 100 years since. Reflectors are much more feasible for larger sizes, and there are many of this type that are extraordinarily large. It is with reflectors that we achieve very large instruments. Reflector telescopes come in two different types. The first type is the single mirror type, where a single piece of glass is cast and polished to make the primary mirror. The second type is the segmented mirror, where a series of hexagonal mirrors are assembled together into a single large mirror. This type of mirror looks much like the honeycomb from a beehive, and this new technology is allowing telescope makers to make instruments larger than ever imagined. The largest single piece of glass telescope in the world is the Large Binocular Telescope, LBT, in Arizona. It is a telescope composed of two separate mirrors that are side by side and work in tandem. The light from both of them are blended into one single image. Each mirror is 8.4 meters, 330 inches, in width, and when used together they create the equivalent of a mirror that is 11.8 meters, 464 inches, across, which is currently the largest light collecting size on Earth. It is located in Mount Graham International Observatory in Arizona. Segmented mirrors pose technology challenges that have been overcome in the past decade, and now these multiple mirror scopes are being built in extremely large sizes that cannot be rivaled by single-piece mirrors. Of the segmented telescopes, where a series of honeycomb shapes are assembled together into a single telescope, there are three different observatories with these largest of mirrors. The South African Large Telescope, SALT, is the largest primary mirror scope in the world, and it has a segmented mirror that is 11 meters, 433 inches, across. The Gran Telescopio Canarias, or GTC, is located on the island of La Palma, Spain, and it has a segmented primary mirror that is 10.4 meters in diameter, 409 inches, which makes it the single largest mirror in the world. The Keck telescopes are a pair of telescopes located at the Keck Observatory in Hawaii. Each mirror is 10 meters, 400 inches, in diameter. Bigger telescopes to come. There are even larger telescopes currently in the proposal, development, or construction stage. Technology improvements over the past decade have made a new scale of telescope possible, and this new scale is referred to as ELT, or extremely large telescopes, and it is the next generation to come. ELTs are telescopes that are more than 20 meters in diameter, which is double the size of existing telescopes. And this doubling of size gives significantly more than double the light gathering power. Most of these scopes will be of the segmented mirror type, but one notable exception is the giant Magellan telescope, which will be composed of 7 spherical mirrors constructed together so they act as a single mirror. This project is scheduled for completion in 2016. It will be located in Las Companas Observatory, Chile. The 30-meter telescope, TMT, which is currently in development, will be 30 meters across and composed of segmented mirrors. It is expected to be a telescope of unmatched performance and is predicted to be able to image planets circling other stars. The current timeline for this project is for it to be completed somewhere around 2017 to 2018. What about the famous Hubble telescope? The primary mirror in the Hubble is 2.4 meters across, 94.5 inches, which makes it rather small compared to some of the giants listed in this video. So then why is it the most spectacular telescope ever created? The big advantage the Hubble has over all the other telescopes is that it doesn't have to peer through the soup of Earth's atmosphere. And this advantage is staggering. That is why the Hubble has brought us some of the most extraordinary images ever recorded. What comes after the Hubble? NASA is currently working on its next-generation space telescope. It is called the James Webb Space Telescope, JWST. The primary mirror will be 6.5 meters, 21.3 feet, in diameter. Launch is planned for 2013. Since the invention of the first telescope 400 years ago, man has been building ever larger telescopes. The telescopes to come will bring us images of planets around other stars, and who knows, they may bring us images of the very birth of the universe we live in. What do you think of our video? Let us know in the comment section below. If you enjoyed this video, make sure to hit that like button. Also remember to subscribe to our channel and enable notifications so you will be the first to know when we upload a new video. Thank you for watching.